All right, so here it goes. So we have way number 2, which deals with matter, and it says that matter is a substance, which could be an element or compound, or a mixture of substances. And this little AQ here stands for aqueous, which means when something is dissolved in water. And we're going to see that in just a minute. And just to confirm, you guys see this screen here with the handout? I just want to make sure you guys can see what I'm doing.
Yeah, we see it.
Excellent. Okay, so we'll start off. And by the way, all the questions that we see here come from, like I said, the last 10 Regents exams. So we're basically, by the time we get through this, we would have gone through 10 Regents exams approximately. So you get to see the patterns, the repetition, and they just ask the same questions over and over again, right around the same question numbers like we're about to see here. So all matter can be classified as. Anybody have an answer? You can either come online or or type it in the chat. Okay, a mixture of substance. Very good, Dylan. So yes, as it says here, it could be a substance or mixture. And so we're going to go ahead with this is going to be choice 4. Okay. And so now let's get into the difference as to what a compound is and what a mixture is. All right. So notice this is question 10 from one test. This is question 9 from a different test. And the next one says, which statement explains why NABR is classified as a compound? So you may know this, you may not know this, but we have a capital letter and a different capital letter. Those represent two different elements that are chemically combined. Okay, they form a compound. All right, so anytime you see two different capital letters, it's going to be a compound. And they're actually telling you that it's a compound. And this is the textbook definition of what a compound is. It's chemically combined in a fixed proportion. And the proportion means we have one sodium and one bromine. Okay, that's Na is sodium, Br is bromine, 1-to-1 ratio. That's a fixed proportion, and that is called that. And they're chemically combined. That means it's a compound. All right. Now, if we go on to the next question right here, number 8, it gives us hydrogen sulfide with a formula H2S. Notice two different capital letters makes it what? What do you think the answer is going to be here for question number 8? Yep, it's compound. So is that choice 1 or choice 2? We know it's not choice 3. It's not choice 4. Is it going to be compound in a fixed proportion or a proportion that could vary?
One.
Yep, it's going to be a compound with with atoms in a fixed proportion. This time though, the proportion is going to be 2 H's to 1 S, 2 to 1. Just like water. Water is H2O, right? If it was H3O, it's not water anymore. So it has to have that's what we mean by a fixed proportion because that defines what the compound is. All right, so very good. That was number 1. And now we're going to go on to another number 9 question from a different test. Which statement describes there's H2O, H2O liquid, and H2O2 liquid? Oh, they look alike, but that right there changes everything. Here we have a 2-to-1 ratio. Here we have a 2-to-2 ratio. So that right there is a completely different compound. Completely different compound. They're both compounds, but if they're different, they're going to have different properties. So we're going to go with choice 2. The second you change the proportion, the ratio, it changes everything. Properties are going to be different. Compounds are going to be different. Does anybody have any question at this point? It's pretty straightforward. Good. All right. And James, feel free to chime in if you have any questions. All right. Let's take a look. We got one more here. Number 9. Which term represents the fixed proportion of elements in a compound? Again, they're telling you fixed proportion elements in a compound. Anybody have an idea on that number 9?
3.
3 it is, yep. So we talked about chemical formula, H2O's chemical formula, H2O2, H2S, NABR. These are all chemical formulas that represent the fixed proportions of elements in a compound. Very good. So I'm going to shift over to this side here. What is represented by the chemical formula PbCl2? What do you guys think? So notice the word compound is not there, but a compound can be classified as, if we look right over here, a substance. A substance could be an element or a compound. Okay, a pure substance. That could be any element or any compound. Now, so we're going to go here with substance. Okay, and all these other things here and some of the other terms that we saw before, like proportions can vary, those are things that describe mixtures. And we'll talk about mixtures in a second as well. Um, let's go to question 36. Now we have a different perspective here on matter, which deals with particle diagrams. And so we have a particle diagram with a key here, and we're looking for a sample of one substance. So again, we're looking for an element or a compound, an element or a compound. And these are all elements here. You have oxygen, hydrogen, chlorine. And so a lot of students get confused with this. So hopefully I can clarify it here. I'm going to skip to, let me move this up right here, to box number 2 for a second. You see we have 2 shaded and 1 unshaded. So that's 2 different elements, and they're touching. That was what we talked about here being, chemically combined and the fixed proportion. So this is 2 to 1, right? And that's this one right here. This is the same thing, also 2 to 1. And all these three here, also all 5. So this would be 5 molecules of the same compound. 5 molecules. Molecule is when you have two or more atoms joined together. They could be the same, they could be different. Okay, so this would be 5 molecules of the same compound, and actually choice 2 is a single substance. So any choice here that does not have choice 2 is going to be out. Okay, now if we look at choice 4, these are 2 of the same. And if you have 2 of the same, that could be a what we call a diatomic element. So an element, E is for element, and we have 2 of the same, so it's a diatomic element, and we actually have 1, 2, 3, 4, 5 molecules of the same diatomic element, and therefore 4. So choice 4 is going to be our answer. But just to go over some of the other boxes here, this is one diatomic element, but this would be a different diatomic element. And there's 2 molecules of this one, and we have actually 3 molecules, 1, 2, 3 of that one. So this would be now a mixture because we have 2 different substances physically combined, they're not touching, in the same box. Okay, so this would be a mixture of diatomic elements. So now that I went through all these boxes, can someone tell me what box 1 represents then? It's okay to be right. It's okay to be wrong. Just no pressure here.
Mixture of substances.
All right, it is a mixture, yes, but what kind of substances are they? Are they elements, compounds, elements and compounds? Because you could have actually a mixture could either be a mixture of elements, like this, box 3. You could have a mixture of compounds, or you could have a mixture of elements and compounds.
Elements and compounds.
Very good. So this right here is we have 2 molecules of a diatomic element, and these are 2 to 1, 2 to 1, 2 to 1, and then we have 3 molecules of the same compound. So this would be a mixture of compounds and element. Actually, it's not even compounds. It's a compound and an element. There's only one element there. That's actually an important point. There's only one element. There's only one compound. There's 2 molecules of the element, there's 3 molecules of the compound. Okay, so we'll probably see a little bit more of this down the road, but one substance is going to be choice 2 and choice 4. Okay, and here is one more, number 40. Which particle diagram represents a mixture? All right, so Dylan says 3. James, you with us?
Yes.
All right. Do you agree? Do you have a different answer?
I agree.
You agree. And what kind of mixture how would you describe it? A mixture of elements, mixture of compounds, or a mixture of elements and compounds?
Elements and compounds.
Yes. So this is gonna be a compound. There's only one compound in there, and there's only one element. But we have 2 atoms of the same element. So yes, that is a mixture of a compound and an element. Very good. Box 1 would be 2 molecules of the same compound. two molecules. This is a different compound than this because the ratio is 1 to 1 versus 2 to 1. And box 4 would be 4 atoms of the same element. Okay, so this time we're looking for a mixture, and so we're looking for choice 3. So guys, how are we doing? This is our first page here. Any questions so far?
All good.
All good? Dylan? All good. All right, so we're going to go on to the next page. We're still on way 2, so this just goes to show you how often these questions tend to be asked. All right, so I'm on page 2 now. And so here we have a way to show how matter can be separated into X and Z. We don't know what X and Z is. They're going to ask us about that right here. And then they give us some examples. Well, if we have one capital letter, that's going to be our element. Here we have multiple capital letters. That's going to be a compound. And what do we collectively call elements and compounds? Substance. So X is a substance. Therefore, Z has to be a mixture. Okay. And oh, you see that right there? The AQ? The AQ is your clue that they're talking about a mixture. Again, AQ stands for aqueous. Aqueous, which means dissolved in water. Dissolved in water is abbreviated AQ. So when sodium chloride, which is NaCl, is dissolved in water, it forms a salt-water mixture. Okay, so Z is a mixture, X is a substance. Air is also a mixture, right? We have nitrogen in the air, that's an element. Oxygen is in the air, right? We breathe in oxygen. We have carbon dioxide, we breathe that out. There's water vapor in the air, and there's a whole bunch of other gases mixed in there, but that's pretty much like the majority of the air. So this would be a mixture. Air is a mixture of elements and compounds. Okay, and oh, look at this question right here. Which sample of matter is a mixture? We're going to go with air because they like to ask the same questions over and over again. All right, so that's it. That's it for way number 2. Um, this is a question on the most recent exam based on stuff that we just covered. Which substance contains elements chemically combined in a fixed proportion? So to be honest, this has doesn't have capital letters or lowercase letters or symbols. But one tip I'm going to give you is in the reference table. Um, so in your reference table, if you go to table S, like Sam, as in Sam, table S has properties of selected elements, and everything listed in table S is an element. And but in this question, they're looking for a compound, which means that 3 of the answers will be from table S, and one of them will not be found in table S. And so to save everybody time here, unless does anybody know or is anybody checking or
2.
2, yes, methane is the answer here. Methane is a compound. The formula for methane, by the way, is CH4, so those are 2 capital letters. Manganese, silicon, and strontium, those are elements. They're all found in table S. So that's an example of something you should be able to answer now after going over way 2. All right, here's another question from the January 2023 Regents. So which sample of matter is a mixture?
3.
3 it is. Anything that gave it away?
The AQ.
The AQ, yes, the AQ, like I showed you right here, is what makes something a mixture, MgCl2 dissolved in water. Very good. And there was a third question there it is. Here, oh, particle diagrams. This is also on the January 2023 Regents. So which particle diagram represents one substance only? Yeah, Dylan says one. And one it is, right? That is a 4 molecules of the same diatomic element. That is one substance. Choice 2 would be a mixture of diatomic elements. Choice 3 would be a mixture of compounds because we have 2 different compounds. Notice the ratio. And 4 would be a mixture of elements. All right, guys. So that is it for way 2. We are now going to, I'm going to go back to the sheet And here we go. On the same page there is way 3. Okay, so we're moving along here. Conservation of matter. Matter cannot be created or destroyed. It can only change forms, and that includes mass, charge, and energy. So our first question, now this is only 2 questions here, so it's not a overly asked concept, but it's an easy concept. So which quantities are conserved in all chemical reactions? What do you guys think on question number 10? Dylan says 2. 2 it is. There it is. Mass, charge, and energy. Mass, charge, and energy. Okay, the order they're written in does not matter. All right, and then during all chemical reactions, here they're telling you charge, mass, and energy are conserved. Conserved. That means whatever you start with, you must end with, right? When things disappear into thin air, they don't really disappear into thin air. They become a new substance and it's now in the air, right? It can't fully disappear. All right, so that's actually it for wave 3, but there is a question from the January 2023 region. So I'm going to switch screens again. And that was, we said, choice 1. Here it is. Now this is going to be a different perspective. You guys see in question 36 on the screen?
Yep.
Awesome. So here's how you want to look at this. It says which equation represents conservation of atoms, which I gave away the answer there, choice 4. But just to go over this, all right, the way it works is, um, here I'll just show you with choice 1. See the two, you have 2 aluminums. And here we have 2 aluminums, but there's a 2 as a subscript. So you actually would distribute this and multiply. So altogether you really have 4 aluminums versus 2. That's not the same. The mass is not balanced. So we could rule that one out right away. Here now, there's 4 and here's 4. That's good, but the O's are not good. Everything has to be balanced, right? You have 2 O's, 3, and this is actually 6 O's because it's 2 times 3. So 2 O's on the left, 6 O's on the right, no good. And if you look at choice 3, oh, now they have 3 times 2, it's 6. And 2 times 3 O's is 6. So the O's are good, but then the aluminums are not, right? So something's always going to be off. But if we look here, we have 4 aluminums, 4 aluminums. Aluminums are good. Here we have 3 times 2 O's is 6. 2 times 3 O's, 6. The O's are good. 3 TIs, 3 TIs. So do we have a good understanding of mass being conserved based on this question there?
Yep.
Awesome. Guys, have any questions for me? Or we're ready to move forward?
Already.
Alrighty. How are you guys liking this so far? Is it good?
Yeah, it's good.
All right, I'm going to switch back to the sheet. And there we go. Now we're going to be on wave 4. Okay, wave 4 still on matter. And this whole session is going to be on matter. We have chemical property, which means that it usually the word react is a giveaway that it's chemical property when there's some kind of chemical reaction. Well, something's going to combine with something else to produce something new. The key here, chemical, something new is going to be getting produced. Okay, so if we look at this, there's a short answer question. And one of my recommendations with short answer questions is they give you this chart, they give you sometimes a passage. I would go straight to the question and read the question first because you might be able to answer it without even reading, some of the stuff here. Doesn't work 100% of the time, but it's a good strategy to start with. So we're stating the chemical property of iodine listed in this table. So we do need to go to the table. We're going to look at iodine right over here. Now we have 1, 2, 3, there's 4 things. One of these is going to be the answer. One of them is a chemical property. One of them means something new is either got produced or is going to get produced. So anytime you see color, something to do with color, physical property. Okay. If they give you a measurement like a temperature, a specific heat, a volume, a density. Those are physical properties. Okay, now we're down to these two. Hold on. All right. So it says there's about 10 minutes left. Worst case, we'll just restart the meet. Um, yeah, and we'll figure it out from there. All right, so the answer here is going to be forms ionic bonds with active metals. So if we're forming bonds, that means something new is going to get produced. That's another way to say react. All right, sublime. Sublime is a good word to know. It's actually way 17. We're going to talk about it down the road. But just so you know, sublime, the word sublime is a phase change. Any phase change is physical because, like ice, when ice melts, it was water before, it's water after. It's still water. Nothing new was produced. So any phase change, and I'll go through the phase changes, is going to be, um, I was going to hear, it's when it goes from a solid to a gas. Solid straight to the gas. That is a physical change. So this is our answer here, chemical change. And chemical property, chemical change are kind of one of the same, like in question 7 here, which statement describes a chemical property? Okay, so a solid, that's a phase, that's going to be physical. Melting, we said was physical. And being attracted to a magnet is physical. So this is a fancy word, oxidize, which means rust. Okay, so when something rusts, when your bike rusts, it could fall apart. It's not as strong as it once was because something new is produced. Okay, so oxidize, reacts. Those are some popular chemical property words. Okay, good. And question 6, and feel free to stop me if you have a question at all. Which information is sufficient to differentiate a sample of sodium from a sample of silver? So we have two elements and we want to be able to tell them apart. Well, they could have the same mass, they could have the same volume, they could have the same phase, but how they react could be completely different. So that is going to be a chemical property here, and that's how we use to differentiate elements, compounds, substances, things like that. Here it is again. Right around, look, we got 7, 7, 6, 7. Chemical properties can be used to differentiate between two compounds. Tell them apart. One reacts, the other doesn't. One burns, the other doesn't. Water and alcohol. They're both colorless, but one's flammable, the other's not. So we can tell the difference. Question 15. At STP, we'll talk about what that means. You don't need to know what that means in order to answer this question. We have 50 grams and 100 grams. So they have a different mass, but this is H2O and this is H2O. Same substance. That means they have to have the same chemical properties. They don't have to have the same volume. They could be at different temperatures. Um, they do not have different formulas, right? They're H2O, H2O. So if it's the same substance, they have the same properties. If they're different substances, they have different properties. Bottom line there. 22. A chemical reaction occurs. Let's see if you guys can pick up on this one. What do you think? 1, 2, 3, or 4? Again, chemical reaction, something new is produced. You guys see anything new there?
4.
Yes, 4 is correct because we're going from O2 to O3. Something new is produced. Here, O2, O2, H2O, 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 same. So these are physical, 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 chemical. And you'll see that a lot. A lot of times, three of them are one, and the odd man out obviously is the answer is going to be the other one. But you kind of need to know your stuff to be able to see that. And hopefully, you guys are getting that from this review session. All right, here are our particle diagrams again, but this time we're looking for a chemical change. Something new is produced. So I'll let you look at those pictures and let you could tell me which one has something new. 4, Dylan says, and that is correct. Here they're far apart, now they're close together, same substance. Here they're close together, now they're far apart, same substance. Here they're kind of far apart, and a little closer together, but same substance. But here we have a compound, right? Two molecules of the same compound breaking apart into something new. We have two of one diatomic element and we have one of a different diatomic element. So that is something completely new, chemical change. Very good. And then we get to 18, chemical change, something new. Now here they don't show a before and after, but they're using some of those words. And remember we said phase changes are physical changes. So well, number one is a physical change. Condensation is going from a gas to a liquid. Evaporation is going from a liquid to a gas. Sublimation we spoke about was a solid to a gas. These are all phase changes. So physical, physical, physical. Synthesis of MgO is your chemical change. All right, and I believe this is our last question for wave 4. This is a short answer question. They give you a reaction. Can you explain in terms of substances in the reaction why the equation represents a chemical change? James, what do you think?
New substances are being produced.
Full credit right there. Full credit. As long as you say something new is produced, you get 1 point. That's how it works. You don't have to write an essay. You don't have to write sentences. You can say something new is produced. Okay? New substance produced. All right. And let's see. I think I'm going to switch over to the January Regents. Share. And let's go. Oh, there it is. Way number 4, January 2023. Let me know what you guys think. Look for a chemical change.
4.
4 it is. Perfect. Good job. And just so you guys know, there's 85 questions on the chemistry regents, 50 multiple choice, 35 short answer in order to pass. I'm sure you guys want to do more than just pass, but just to let you know, to pass, you need 50 points. That's 50 out of the 85 questions, any combination of multiple choice. I actually tell my students, you could get every multiple choice question right and pass with just the multiple choice because you need 50 points and leave the rest blank. Now, chances are if you get all the multiple choice right, you probably do well on the short answer too, and which you should, finish the whole test. But 50 points equates to a 65. So my goal for everybody is to get you to more than just pass. So let's go back here. So yeah, that was going to be choice 4. And oh, here's one more from the January 2023 Regents. Now, this question's worded a little bit differently, but it's the same idea. Physical equilibrium. Physical, what do you think is going to happen in physical? If chemical was something new, physical is going to be what?
Remains the same.
Remains the same. So do you see the answer already?
4.
Yes, it is. 4 it is. Nitrogen liquid, nitrogen gas, that's a phase change, and that is the correct answer. So um, that was wave 4. And let's see. Yep, wave 4, we finished that. All right, we're going to go on to way number 5. Let me switch back to our sheet. Here it is. And share. All right, so way number 5, still on matter, cannot be broken down or decomposed. Sometimes those words are used interchangeably. And cannot be broken down means we talk about an element. And like I told you before, all elements are listed in table S, or actually should say, sorry, only elements are listed in table S. So if you can see here in question 10, which type of matter cannot be broken down? There are the key words, cannot be broken down. We're looking for an element. All right. The next question, again, if you take a look, these are all, this is 10, 14, 14, 13, 11, 12, 8, all technically right around the same number. And sometimes they do ask this as a short answer question, but more popular as a multiple choice. Here it is again, cannot be decomposed. We're looking for an element, and as you may recall from way 2, an element will only be one capital letter. The rest are compounds. Number 14, cannot be broken down. Now here it's a little bit more specific. If you don't know your elements, you can always go to table S. Only one of them will be listed. The other three will be compounds. So anybody have an answer? 14 for this question here?
3.
3 it is. Tungsten is an element. Water is compound. Ammonia, compound. Ethanol, compound. And next up, cannot be broken down. Again, we're looking for an element. And notice they're even using the same choices. This is a compound. Water is a compound. Um, Methane we spoke about earlier is a compound. And magnesium is the element. Choice 2. It's going to be an element every single time they say cannot be broken down. So for number 11, do you guys see the element?
1.
Yes, it is. Aluminum's the element. The only one listed in table S. Question 12, cannot be broken down. I don't know if you guys realize this, but this, methane, water, ethanol, here they use methane, water, ethanol. So this time it's going to be antimony. Antimony is your element. The other three are compounds. And this time, be careful here, can be broken down. This time we're looking for a compound. That means 3 of the choices will be elements, and the other odd man out will be the compound. And it's the same compound they keep talking about here, ammonia, ammonia, ammonia. All right, guys, that was wave 5. Let me switch out to the January Regents 2023. All right, so this was a question on that exam and right around question 13. Let me know when you guys have your answer.
3.
3 it is. And again, they use ammonia, ethanol, water. So that is choice 3, and there it is, krypton in table S of the reference table. Choice 3. All right, let me switch back to our sheet. And on the same paper, we have way 6, still in matter. This is distillation. Now, the textbook definition of distillation is using boiling point differences to separate substances. So, question 17. Distillation is a process used to separate a mixture of liquids based on different boiling points. It's easy as that. Here's another one. 2 liquids. This time they're using the word again. Boiling point. So when you see distillation, boiling point. This question here, this apparatus, this is actually what a distillation apparatus looks like. So you basically have like a flask of some sort with a mixture. Like you could take alcohol and water, they're both colorless, right? You can't separate them with a filter, so you could use their boiling point differences to separate them. So you want to be familiar with this. This was actually on a recent exam. It might have been, I think, August 2022. And they said this apparatus is used for which process? And so this is what distillation looks like. So when you heat it up, one liquid will boil out, get trapped here and get cooled down. The other one, who has a different boiling point, is not going to boil out. It's going to get left behind. And thereby you can separate the two liquids using their boiling point differences. It's called distillation. And here it is as 2 short answer questions. Identify a laboratory process that can be used to separate a liquid mixture of methanol and water. That's alcohol and water. And they're telling you what to write. So what are you going to write for 52? One word, 1 point.
Distillation.
Boom, there it is. Distillation. And describe a procedure to remove water from a mixture that passes through filter, collects in the beaker. You could say evaporation, but you can also say distillation. Either one of those would be acceptable there. And there you have it. That's way 6. And I don't believe there was a question on the January Regents, but you get the idea. Do you guys have any questions for me whatsoever? We do have one more way to cover for today, but I'll pause if you guys have anything for me.
I'm all good.
All good? Very good. So we'll continue, and then this will be our last one for today. So this is allotropes. You may not actually see this word, but you're probably going to see these examples, which is O2 and O3. That's oxygen, that's ozone. You may also see diamond and graphite. So these go together, and diamond and graphite go together. And these are the two popular examples they love to ask about, which are two forms of the same element in the same phase, but they're going to have different structures and therefore different properties. So O2, O3, two forms of the same element that have, what do you think the answer is for number 7?
2.
Not 2, because remember when you have these two, O2 and O3, this is always going to be different, different structure, different properties. So we're going to go choice 4. Okay. And here is another. This is O2, O3. Different way to represent it. These diagrams represent substances that have, what do you think?
4.
Different. That it is. And move on to this one here. Let me, this time they're talking about diamond and graphite. That was the other example that's in the study guide here, diamond and graphite. And so diamond and graphite have different properties because they have different, let me zoom in a little bit over here. What do you guys think there?
1.
That it is, different structures, different properties. And then we go to the top right over here. Again, they're talking about graphite and diamond. So by now, when you see graphite and diamond, you already know they're probably asking about allotropes. When you see ozone and oxygen, they're most likely asking about allotropes, which again have different structures, different properties. Here it is again, different test. Number 7, graphite and diamond are two forms of solid carbon. These forms have different. Here it is again, different test. Graphite and diamond. Which statement explains the different properties? What do you guys think on 34? All right, Dylan, very good. 3 it is, different structure. Okay, and so that is it for way 7. That is it for today, but I do have one more question to present to you from the January 2023 Regents. Let me know when you have your answer.
3.
3 is correct.